In this video, we will be taking our basic factoring skills of greatest common factor, trinomial factoring, and difference of squares and extend it into some sort of grouping or something that involves substitution or combining everything in one big factoring question. So our first factoring question is the following. 2x plus 3 all squared minus 4x minus 5 all squared. Instead of doing distributive property, which would be tedious and potentially you could make quite a few silly mistakes, we could see this as a difference of squares. I have a bracket squared, so something like something squared, minus another bracket squared. And let's say that bracket is b squared. And that's a difference of squares. And if you were to factor that, that would just be a plus b times a minus b, where a and b are the square roots of the terms that you initially have. So if I were to square root each of these brackets, well, the square root would cancel out the exponent of 2. So for our first bracket, I'm going to open up a big giant bracket here, I would have 2x plus 3 plus 4x minus 5, and then in another bracket, 2x plus 3 minus 4x minus 5. And I did go a little bit overboard with my brackets. The brackets in here don't make a difference. The brackets around 2x plus 3 don't make a difference. The only ones that matter are around the 4x minus 5 because we have to distribute that negative in, which we will do in the next step. So I have 2x plus 3 plus 4x minus 5, and then 2x plus 3 minus 4x plus 5 because of that double negative. And now we can just collect the like terms in each bracket so that we have 6x minus 2 and then negative 2x plus 8. And now actually when I look at this, each of my brackets has a greatest common factor inside. So in this first one, I can factor out a 2. So that will give me 3x minus 1. And in the second one, I can factor out a negative 2, which would give me x minus 4. And then I can take both of those GCFs and multiply them to get negative 4 times 3x minus 1 times x minus 4 for my final answer. So this was a difference of squares with a very small twist. The next example we have 2a squared times a minus 2, so let's look at that as a term, plus 3a times a minus 2, let's look at that as a term, minus 2 times a minus 2. Let's look at that as a term because the components are attached by multiplication. If you look at the individual components, each part has that a minus 2 bracket in common. So we could do a GCF of a minus 2. Instead of just factoring a monomial, we can factor out this binomial bracket that they all have in common. And remember, when you're doing a greatest common factor, you're just dividing each of your terms by that common factor. So when I divide this term by a minus 2, it cancels it out and we're left with 2a squared. When I divide this term by a minus 2, cancels it out and we're left with 3a. And if I divide this by a minus 2, we're left with the negative 2. And once we do this greatest common factor of a bracket, we're left with a trinomial that we can try to crisscross, or whatever method you prefer for trinomials. So 2a times a, and I'm going to do 2 and negative 1 like this. That way I have 4a and negative 1a, and these add up to 3a, which was the middle term. So that's perfect. And I can finish this off. A minus 2 times 2a minus 1 times a plus 2. Reminder that with crisscross, you're writing your brackets horizontally. The crisscross is just for your check. Okay, let's try another example. I have y squared plus 1 times y plus 2 minus 5 times y plus 2. Again, I see two components. I can see that as a component because they're attached by multiplication, and this as a component. And each of these components has a common y plus 2 bracket. So let's factor it out. When I factor y plus 2 from my first component, it would cancel this out. So we're left with y squared plus 1. And when I factor it out from the second, it would cancel this out, and we'd be left with minus 5. Now I have something to clean up in my second bracket. And we will have y squared minus 4. And remember, you must check your brackets to see if you have fully factored. Here, we have a difference of squares. So I'll keep my y plus 2 from the original, and y squared minus 4, when I factor the difference of squares by square rooting, we'll have y plus 2 and y minus 2. And you can keep your answer like this, or if you would like to clean it up further, because you have that y plus 2 bracket twice, we can write y plus 2 all squared. All right, on to the next one. I have 2a squared plus 5a all squared minus 10 times 2a squared plus 5a minus 24. And again, I have three components, but unlike the previous one, these three components don't have anything in common. They don't have that bracket in common to say, oh, I'm just going to factor it out. But what we can do is temporarily make this a little easier for ourselves. Let's replace 2a squared plus 5a. Let's replace it with x, or whatever variable you would like. So what we have is x squared, the bracket squared, minus 10 times the bracket, so minus 10x minus 24. And when you look at this, this looks like a simple trinomial to factor. We could do x times x, and then negative 12 times 2, that's negative 12x, that's positive 2x, hooray, that works. So then we're left with x minus 12 and x plus 2. But we have to remember, wait a second, our original expression didn't have x's in it, it had a's in it. So we need to remember this little modification we made. We replaced those brackets with x's. So let's replace our x's back with what they're supposed to be. It's supposed to be 2a squared plus 5a. So I'll go back into each of my brackets and do the swap. And if you look at what we have now, each of our brackets is a trinomial. We could do another set of crisscross if possible. I mean, it's not always going to work out to be beautiful and more factoring to be done, but in this case, let's give it a try. 2a times a, and then I need to multiply to negative 12. So maybe 4 like this and negative 3. That way we have 8a, negative 3a, 8 and negative 3 add up to 5, so that's good. So we would have 2a minus 3 and a plus 4 for the first bracket. And now for the second, again, 2a times a. And here it has to be 2 times 1. I just have to think carefully how to lay it out. This is going to give me 4a. That's 1a. That adds up to 5. So that's good. So that's 2a plus 1 and a plus 2. And there we go. We went from something that looked pretty overwhelming, cleaned it up, made it simpler with that little substitution, did regular crisscross, brought back the a's, and did some more crisscross. This was really just a triple crisscross question. All right. So in the examples we've just done, there's been some sort of fancy bracket that we could either do a common factor for or sub it out to do a nice crisscross, or we had fancy difference of squares. In the next few examples we're going to look at, there aren't going to be brackets. We have to bring them in. And the process or the method we're going to be using is grouping. And there's a lot of freedom to grouping in that you can group your terms however you'd like to try to get something common or bring in a familiar method later on. When you have 4 terms, you can group them 2 by 2 or 3 by 1 or 1 by 3. The more practice you do, the faster you'll get at looking at an example and realizing which way to group things. But when we look at our first set of questions, I don't see anything common to these 4 terms. And even if I look at my first 2 terms and my last 2 terms, if I were to say, oh, I'm just going to pair them up like this, there's nothing common between those pairs. However, I would love to see the px and the py together and the 2y and the 2x together. So I'm going to rearrange this first. So px plus py plus 2x plus 2y. So I haven't changed any of the signs. I just rearranged things. And now I'm going to pair these up and see if there's a common factor within each pair, which there will be because I rearranged it like this for a reason. The first pair has a p in common. So I'm going to factor out the p and I'll be left with x plus y. The second pair has a 2 in common. So when I factor out, or when I divide out the 2, I'm left with x plus y again. And now we're back to a question we already did. Treat these as 2 components. That's a component, that's a component. Each component has this x plus y in common. So I can factor it out. I'm doing a common factor here of a bracket. When I factor out x plus y, or I divide it out from the first component, it cancels it out, and you're just left with p. When I do it for the second, we're left with 2. I check my individual brackets, that's as far as I can go. So now I can move on. The next expression, 3a cubed plus 6a squared minus 12a minus 24. Well, first thing that pops out at me is they're all divisible by 3. So I'm going to do a GCF to start off with. At least make my numbers a little nicer before I continue. Now, if I look at this, there's nothing else left in common. So I'm going to try to just do a 2 by 2 pairing and see if that works. Now, because I've already taken out a common factor, I'm going to open up this big giant bracket to do my grouping inside. My first pair, they both have a's in common, and not just a single a, an a squared, because the first one is cubed and the second one is squared. And that will leave us with a plus 2. In my second pair, which is negative 4a and negative 8, if the first term in your pair is negative, you factor out a negative, and they're both divisible by 4. And that leaves us with a, and then careful with your signs here, negative 8 divided by negative 4 is positive 2. And here's the sign that you're on the right track. If when you group and you do your common factor within each pair, if you end up with a common bracket, that means good job, that was a good strategy. So now that our brackets match, I can factor out the a plus 2 from each component. So when I factor it out from the first component, the a plus 2 cancels out and you're left with a squared. When I do it for the second, the a plus 2 cancels out and I'm left with the minus 4. And look at what just opened up. Now we have a difference of squares. So 3 times a plus 2, and then the difference of squares, when I square root, will be a plus 2 and a minus 2. You can stop there, or if you'd like to write that a plus 2 as an a plus 2 squared, no problem. And there we are. Here we had a GCF, a grouping, which is really just fancy GCF, and a difference of squares. For our next one, we have x squared minus 6x plus 9 minus 49y squared. When I look at this, if I were to try to pair them up, there's nothing common in these pairs. I mean, I can factor out an x from the first pair, but nothing from the second pair. So that tells me right away that's not a good strategy. 2 by 2 will not work. But when I look at the first 3 terms, they look like a nice little trinomial. So I'm going to do a 3 by 1. So when I see that trinomial, there's no GCF, but I can try to just put a little set of brackets because it's the first 3 terms. And let me just see what happens when I crisscross this. X times X, 3 times 3. But if I want my check to be negative, I should put 2 negatives. That way the 2 negative 3's multiply to positive 9. But when I crisscross, I'll get that negative 6. So it's the same bracket twice. So I'm going to write it as x minus 3 squared minus 49y squared. And that just opened up a fancy difference of squares because I have 2 terms. One of them's a bracket squared, and then another term, and they're both perfect squares because they can both be square rooted. So when I square root this, it just cancels out the exponent of 2. And when I square root 49y squared, that's just 7y. So if we put that together for our difference of squares, I'll have the x minus 3 for when I square root the bracket squared plus the 7y, and then x minus 3 minus the 7y. And in terms of factoring, that's as far as you can go. In terms of trying to clean it up, you can always put things in proper order. X, y, then constant. But there we go. That's not really factoring related. All right, on to the next one. M squared plus n squared minus 81 minus 2mn. If I try to do pairing up like this, there's no common factor here or here, so I'm not happy with that. If I try to do a 3 by 1, again, that's not even a nice trinomial that's crisscrossable because it's not in the proper format. So that's no good. However, if I am thinking of maybe I want to do crisscross at some point, if this term here could be squished between the m squared and n squared, maybe that's a trinomial I could factor. So before I do any grouping, I'm going to try rearranging. And notice when I rearrange, I am not changing any of the signs. The 2mn had a negative in front of it. That negative came with it. I didn't change it. I just moved it somewhere else on the same side. And now I'm going to look at this pair and see if I could do crisscross. Well, m times m is m squared. N times n is n squared. But I see my check has to be negative, so just like last time, I'll just make both of these negative. That way, I'll have negative mn and negative mn, and those do add up to negative 2mn. So that's great. So m minus n all squared minus 81. And now we're back to the same thing. We have a difference of squares after that grouping. So we'll have m minus n plus the square root of 81 is 9, and then m minus n minus 9. And now it's nice and factored. All right, for our next one, x squared minus 6x plus 9 minus y squared minus 4y minus 4. We have 6 terms here. So a 2 by 2 or 3 by 3 or 3 by 1, will not work. But a 3 by 3 might work, and that would be kind of perfect here because it looks like I have 2 sets of trinomials. So x times x, 3 times 3, but both negative for the check to work. Negative 3x, that's negative 6x. But for the second one, I can't just put random brackets around it like I would have for the first term. So what I have to do first to get those brackets in, I have to factor something out. And because the y squared is negative, I have to factor negative 1 out. And that's going to give me y squared plus 4y plus 4. It didn't matter for the first 3 terms because the coefficient of y squared was positive 1. So I could put brackets around it, no problem. And now, for the second trinomial, we'll have y times y and 2 times 2. That way we have 2y and 2y, which is 4y. And now we're back to the first example of a fancy difference of squares. So I'm going to square root this term and square root this term. And that's going to give us x minus 3 plus y plus 2. Notice I don't care about brackets here. And x minus 3 minus y plus 2 in brackets, because I'm going to have to distribute that negative in, and the brackets will make a difference. So now I'm going to clean up. X plus y minus 1 when I clean up or collect the like terms. And then x minus y when I distribute that in. And when I distribute the negative into the 2, it'll be minus 2. So negative 3 and negative 2 is negative 5. And if you wanted to do that in 2 steps, no problem. And now that's factored. All right, last example. X squared minus 2 all to the 4 minus 13 times x squared minus 2 all to the 2 minus 36. So this question is similar to another one we had, which is some of our terms or components have the x squared minus 2 in common. So I'm going to swap it out. Let's let a equal x squared minus 2. I can't use x because we already have x's in the actual question. So that's going to be a to the 4 minus 13a squared minus 36. Now I'm going to factor. I'm just going to factor on the side here. A squared times a squared would give me a to the 4. Now I realize I made a little typo. I would like the 36 to be positive, so I'm just going to fix that for us. And now I need to multiply to positive 36, and it's going to be 2 negatives. So negative 9 and negative 4. That way we have negative 9a squared and negative 4a squared, which add up to negative 3a squared. But when I multiply the 2 negatives, I'll get that positive 36 that I fixed. So that's going to be a squared minus 9 and a squared minus 4. Before I bring in that x minus 2, I notice that these are difference of squares. So I'm going to factor them. So a plus 3, a minus 3, and a plus 2, a minus 2. Now that I'm done factoring this, I'll bring back the x squared minus 2 and see what happens. X squared minus 2 plus 3, x squared minus 2 minus 3, x squared minus 2 plus 2, and x squared minus 2 minus 2. So that gives us x squared plus 1. That's done. That's not a difference of squares. That's as far as we can go. X squared minus 5. 5 isn't a perfect square, so that's as far as we can go. This is just x squared. And then we have x squared minus 4. This last one can be a difference of squares. So let's finish that off. I'm actually going to take this first term, or that x squared, and make it my first term because it's just a monomial. That just looks a little cleaner to me. I'll rewrite the other ones. And then the x squared minus 4, I'll write as x plus 2 and x minus 2. And there we are. We did crisscross, we did difference of squares, we did substitution, a very full question. So if you see multiple terms, you should be thinking of grouping. 2 by 2, 3 by 1, 3 by 3. If you see common brackets to all your components, you have a giant GCF. If you see brackets squared with subtraction, you have fancy difference of squares. If you see overwhelming brackets that aren't common to all of your components, think of substitution. And then you're just mixing and matching from skills that you already have. And that's it for our factoring extension and challenge.